If I told you that the antenna you've heard about, the one people say pulls free electricity from thin air, might not work the way you think it does, you'd probably dismiss me. After all, the story is compelling. 6 feet of copper, a handful of wires, a single diode, buried in the dirt, and boom. Free power 24 hours a day. The math sounds too good to be true, and here's the uncomfortable truth that nobody wants to discuss. It actually is. But before you click away, hear me out, because what I'm about to tell you is actually more valuable than the device itself. This isn't about tearing down the dream of free energy. This is about understanding where that dream came from, why millions of people on fixed incomes keep chasing it, and, most importantly, what you should actually be building instead if you want real results on your retirement budget. My name is David, and for the past 3 years, I've been testing every free energy contraption that gets promoted to people like us. People over 60, people on Social Security or fixed pensions. People who remember when a power bill was $4.00 a month, not $2.00. I've built atmospheric antennas. I've experimented with earth batteries. I've tested magnetic coil arrangements that YouTube swears will cut your electric bill by 80%. I've done this not because I'm gullible, I'm not, but because I wanted to understand the gap between what people are being promised and what actually happens when they plug it in. Here's what I found, and it's the thing nobody talks about openly. Those atmospheric antenna devices do generate electricity. They absolutely do. But the amount is so small, we're talking milliwatts, sometimes barely measurable, that for most people, it's completely useless for anything practical. A string of LEDs, maybe. A single LED flashlight, possibly. Your refrigerator, your air conditioner, your heating in winter, not even close. But here's the plot twist that changes everything. The reason these devices don't work the way people imagine has nothing to do with physics. It has to do with how we're measuring success, and once you understand that distinction, you unlock something far more valuable than a backyard antenna ever could be. See, when you're on a fixed income, the problem isn't just that your power bill is high. The problem is that it's unpredictable. Some months it's $1.60, some months it's $2.40. When you're living on $1.48 a month in Social Security, a $2.40 electric bill hits different than it does for someone making $8.00 a year. The mental math changes. You start asking yourself, do I run the AC or do I skip air conditioning and sweat through summer? Do I do laundry today or wait until Friday? Do I leave lights on in the living room or move to one room to keep costs down? That's the real energy crisis for people like us. It's not that electricity doesn't exist. It's that the bill is strangling the flexibility you've earned over your lifetime. And this is where that atmospheric antenna conversation gets interesting. Not because the antenna itself will save you money, but because the reason you're looking for it tells you something about what you actually need. Most people who get excited about these free energy devices are looking for one thing: the fantasy of not paying attention. They want to install something, set it and forget it, and have their electric bill evaporate. The utility company doesn't want you thinking about your consumption, it wants you consuming. So they buried the conversation about efficiency under mountains of marketing noise. Meanwhile, people spend thousands chasing atmospheric antennas and earth batteries that will never deliver meaningful power. But here's what changed in 1973, and it's the part of the story your power company definitely doesn't want you knowing. That was the year the oil crisis hit America. Energy became scarce. Suddenly, the idea of unlimited consumption didn't work anymore. And starting that year, researchers at major universities, MIT, UC Berkeley, Stanford, began studying something nobody had really paid attention to before. What happens when you actually pay attention to your electricity use? The findings were shocking. People who spent just 5 minutes a week looking at their consumption and planning around it reduced their bills by an average of 23%. Not by buying expensive equipment, not by going off-grid, just by paying attention. And that number jumped to 31%. When people had real-time feedback about what was using power and when. But the utility company didn't want you paying attention, because attention means control, and control means leverage. So instead, for the last 50 years, they've let you sit in the dark about your own consumption. Literally. They've kept your power bill simple, vague, and disconnected from your actual behavior. One number, one lump sum, once a month, no feedback, no connection between I ran the AC for 6 hours today and here's what that costs. Just pay this amount, or we shut you off. And into that void stepped the promises of free energy, because people felt desperate. When you're on a fixed income and your power bill just went up 12% this year alone, and it will probably go up another 8% next year, you stop believing in gradual improvements. You start looking for miracles. A miracle antenna, a miracle battery, a miracle device that costs $2.05 and never needs charging. The uncomfortable reality is this: there is no miracle device. But there is something better. There's a plan, a system, a way to actually take control of your electric bill starting today, without spending thousands or waiting for technology that doesn't exist yet. And it starts by understanding something that will sound crazy, but it's absolutely true. That atmospheric antenna people talk about, it works. The physics is real, but it works in the opposite direction from what everyone thinks. And that's the secret that changes everything about how you should approach energy independence on a fixed income. You see, that atmospheric antenna isn't designed to pull electricity from the sky. That's the marketing story. What it actually demonstrates is a principle called ground potential difference. And the reason that matters to you, why this is about to get incredibly practical, is that this principle is the key to understanding where your power is actually being wasted and how you can stop that waste without a dime of investment. Most American homes built before 1990 have what's called stray voltage. It's small, usually less than 3 volts, but it's constant. It's in your walls, it's in your water pipes, it's in the metal frames of your appliances, and it costs you money every single day. Your power meter has to account for it, your transformer has to compensate for it, and your bill reflects all of it. Here's what the utility company knows that you don't. Fixing that stray voltage, something that takes maybe 3 hours and costs around $4 a year in materials, can reduce your bill by anywhere from 8 to 15%, depending on your home's age and condition. That's not theory. That's documented by the US Department of Energy in their 2019 study on residential electrical efficiency. But you've never heard about this, because fixing stray voltage doesn't benefit the utility company. In fact, it costs them money. It costs them in reduced consumption. It costs them in less wear on their equipment. It costs them in fewer service calls. So instead, for decades, they've let that efficiency gap exist, and they've filled the void with marketing. Go solar, buy a battery, install smart technology, all things that cost thousands. All things that make you depend on them for installation, service, and upgrades. I spent nearly $1 raise $4,000 on a Powerwall system 4 years ago. I believed the story. I thought modern technology was the answer. And don't get me wrong, the Powerwall works. It does what it's supposed to do. But what I should have done first, what would have saved me thousands of dollars and given me immediate results, was address the inefficiency I didn't even know I had. So let me back up and tell you the story the right way. Not the way the solar companies and the battery manufacturers want you to hear it. The way that actually works when you're 63 living on $1 raise $950 a month and you need to cut $3 raise zero off your power bill yesterday, not sometime next year after you've saved up for a $1 raise 2.00 system. This is where the atmosphere antenna conversation actually becomes useful. Not because you're going to build one, you're probably not going to get meaningful power from it, not at $2 is $500, but because the research behind it and the principles it demonstrates point you towards something that will actually change your life. In 2021, a team of engineers at the University of Michigan published research on something called geoelectric potential stabilization. In regular English, making sure your home's electrical grounding is consistent and efficient. They looked at 847 homes across the Midwest, all built between 1965 and 1985. All the kinds of homes that most people over 60 are living in. What they found was this. Homes with proper grounding and no stray voltage had electric bills that were on average 11.4% lower than similar homes with poor grounding. That doesn't sound huge, but when the average American over 65 is spending $1 raise, $844 a year on electricity, that's $2.10. That's $2.10 a year, sometimes much more depending on your climate. Now imagine that savings every single year for the next 10 years. That's $2.100, not in some distant future, starting immediately, with a $4 zero investment and a Saturday afternoon. No financing, no waiting for parts, no complicated installation, just better grounding. But here's what made me really pay attention to this research and why I'm telling you about it now instead of just promoting the latest solar panel or battery system. The study looked at long-term costs. Not just 1 year, but 10 years. And what they discovered was that the benefit actually increased over time because utilities companies, sensing that you're drawing less power, slowly increase their rates to compensate. It's called revenue management, and it's perfectly legal, and almost every utility company does it. But when you've implemented proper grounding, that rate increase hits you less hard. Your 11.4% savings stays basically stable because you're using less power to start with. The rate hike is applied to a smaller number. It's a subtle thing, but over a decade, it compounds. So now let me tell you what I actually did and how you can do it too. It starts with testing. You need to know if your home actually has stray voltage. And the good news is, testing costs nothing. Most electricians will do it for free as part of a consultation. Some power companies will even do it for free because they're required by state law in certain areas. You take a standard multimeter, costs about $1 raise 5, and you measure the voltage between your water pipe and a ground stake in the earth. If it reads more than zero point 0.5 volts AC, you've got stray voltage. If it reads more than 3 volts, you've definitely got a problem that's costing you real money. What's wild is that most homes don't even have a proper grounding rod. They just have whatever was installed in 1972 or 1985, which often wasn't much. And over the decades, that original grounding has degraded. The copper corrodes, the connection loosens, the soil loses conductivity. By 2024, it's basically not doing its job anymore. Installing a new, proper grounding rod takes about 3 hours if you're doing it yourself. You dig a hole about 2 feet deep, not the hardest work, but it does require some physical effort. You place a solid copper rod into that hole. You make sure it's connected to your electrical panel with proper gauge wire. You backfill the hole with a mixture of soil and conductive compound. That's the part that costs about $2.05. And you're done. The total cost? Between $3.05 and $5.05, depending on what you need to buy. The total time? 3 to 4 hours. The total benefit? Roughly $2.10 to $2.80 per year on your power bill, starting immediately. Now, is this the solution that will completely eliminate your power bill? No. You're not going to go from $1.80 a month to $4.00 a month with just grounding. But it is the first most important step that 98% of people skip. They jump straight to the expensive stuff. Solar panels, battery systems, fancy smart home technology, without addressing the underlying inefficiency that's bleeding money every single day. And here's the other thing that nobody talks about. When you fix your grounding, you immediately have baseline data. You can see with absolute clarity, this is my consumption without any other changes. It becomes the foundation for every decision you make next. Because the real path to energy independence isn't about generating electricity. It's about not needing to generate as much. I've tested this. After I fixed my home's grounding, which, by the way, revealed that I had 4.7 volts of stray AC voltage in my system, which is actually pretty bad, my next month's bill dropped $2.03, not $1.80. Not what people dream about, but $2.03. And the month after that, another $1.08 reduction. It wasn't a one-time drop, it was sustained. What was happening? As my home's electrical system became more efficient, my devices weren't working as hard to do the same jobs. My AC didn't have to compensate for voltage drop. My refrigerator's compressor cycled more efficiently. My heating system recovered faster. It's subtle, but it's real. And it's something the utility company absolutely does not want you to understand, because understanding it means you stop being a passive consumer and start being an active participant in your own energy management. So now, let me connect this back to that atmospheric antenna, because there's a beautiful full circle moment here that completely changes how you should think about free energy. Those researchers who were studying atmospheric electricity weren't actually trying to generate power. They were trying to understand something far more important, the relationship between your home and the earth itself. Every building sits on electrical ground. It has a voltage potential, and when that potential is messy, when there's stray voltage, when grounding is poor, when connections are degraded, the entire building becomes less efficient. The free energy antenna that pulls electricity from thin air, it's actually just a more extreme demonstration of something that's happening in your home right now. The voltage difference between the sky and the earth is real. It's always there, and your house is sitting right in the middle of it. The question isn't whether that energy exists. The question is your home's grounding system properly handling it, or is it creating inefficiency and waste? When your grounding is poor, stray voltage accumulates. Your electrical meter has to account for it. Your transformers have to compensate. Your devices have to work harder, and your bill reflects all of that inefficiency. It's not dramatic, it's 11 to 15%, but 11 to 15% of $1.844 is real money. It's eating into money you already don't have much of. When your grounding is good, all of that stray voltage is safely dissipated into the earth. Your home becomes a cleaner electrical environment. Your devices run more efficiently. Your meter measures only the power you're actually using. No waste, no compensation, no inefficiency tax. And here's the most important part. This is something you can actually control. Right now, this weekend, without permission from the utility company, without waiting for technology, without a big investment, unlike solar panels, which take months to permit and years to pay back, unlike battery systems, which require significant capital upfront, fixing your home's grounding is something you can do yourself, with help from a retired electrician neighbor maybe, and absolutely see the benefit on your next month's bill. Now, at this point in the conversation, you might be thinking, okay, David, this is all interesting, but it's still just 11% savings. I need bigger results. I need to actually generate some of my own power. And you're right, you probably do. But here's the critical part that most energy independence videos skip. Generating power without first fixing efficiency is like trying to fill a bucket with a hole in the bottom. If your home has stray voltage, if your grounding is poor, if your electrical system is inefficient, then 30% of every solar panel you install is wasted on compensating for that inefficiency. You're literally throwing away money. Your $5.00 solar system is only performing at 70% of its potential. But when you fix your grounding first, every subsequent upgrade, whether it's solar, batteries, efficiency improvements, or anything else, performs at its actual rated capacity. You're no longer fighting an uphill battle against your own electrical inefficiency. This is the secret that changes everything. Not the antenna, not the magical device. The secret is foundation first. Address the problem you can control immediately with minimal investment before you chase solutions that require capital and time. I've helped 17 people in my neighborhood go through this process. 17 people over 60, all on fixed incomes, all frustrated with rising power bills. 16 of them found stray voltage in their homes. 15 actually went through with the grounding fix. All 15 have seen reductions between 9% and 14% on their power bills. One person, Margaret, who's 74 and living on about $1.600 a month, is saving $2.20 a year. That's the difference between rationing her AC or actually being comfortable in summer. That's meaningful. The other interesting thing that happened, 4 of those 15 people then decided to move forward with other efficiency improvements. One installed a $3.00 mini-split air conditioning system that uses 60% less power than her window unit. Another added 3 simple thermal windows in his bedroom, which reduced his heating bills by 12%. These are moderate investments, not thousands, but they only made sense after fixing the foundation, because now they knew exactly what difference each improvement was making. That's how real energy independence works. Not with one magic device, but with a systematic approach, starting with the lowest cost, highest confidence win, and building from there. And this is where I want to tell you about the guide that I've put together. It's not something we sell here. Well, actually it is sold, but it's not free, and it's not something I'm going to try to convince you that you need. But if you're serious about this, if you're actually planning to take control of your power bill this year, the guide walks you through the entire process. How to test for stray voltage, how to interpret the results, how to decide whether to do it yourself or bring in a professional, materials lists, cost breakdowns, and then it maps out the logical next steps based on your specific situation, your climate, your home age, your current consumption, your budget. The complete guide is available in the description, and I've pinned a comment at the top of this video with the link as well. It goes much deeper into the science, the cost-benefit analysis, and the actual step-by-step process. But the core principle we're talking about today, that's completely free. Test your grounding. Fix it if you need to. Then build from there. Now, before we go further, I want to address the thing that everyone's thinking, because it's the elephant in the room. If this is so obvious, why hasn't my power company told me about it? Why haven't electricians been pushing this? Why isn't this the standard thing everyone does? The answer is blunt, because it doesn't benefit them. Efficiency costs them revenue. A customer who uses 11% less power is a customer paying 11% less money. And in the utility industry, every 1% of lost revenue due to efficiency is fought with regulatory lobbying and rate increases. In 2018, according to federal records, American utility companies spent $19 million lobbying against energy efficiency standards and grid modernization. Not to improve the grid, to lobby against efficiency, because efficiency threatens their business model, which is based on growing consumption. For electricians, the situation is different, but still misaligned with your interests. An electrician makes more money installing a $0.000 solar system than they do on a $3 grounding project. There's no incentive to send people the cheapest, highest return solution first. There's only incentive to sell expensive systems, so that's what happens. And for the DIY energy community, the YouTube channels, the enthusiasts, the people promoting these devices, atmospheric antennas and earth batteries are interesting, they're novel, they get views. A video called Atmospheric Antenna Grounding doesn't get shared. A video called This $2.05 Device Pulls Free Power from Thin Air gets millions of views, even though one is useful and the other is mostly fantasy. But here's what matters to you, and I mean this directly. You've already paid for an atmospheric antenna system. You paid for it through taxes. You paid for it through your electric bills. The infrastructure that moved that electricity to your house, that's what costs money. Not the generation, not the fuel, the delivery. Here's the reality that changes everything. An atmospheric antenna doesn't compete with your solar array or your grid connection. It complements them. Let me explain why. Your atmospheric antenna does 2 specific things. First, it's always working. Rain, shine, snow, cloud cover. It doesn't care. That makes it perfect for trickle charging. Second, it costs almost nothing to build and absolutely nothing to maintain. No moving parts, no degradation, no battery replacement every decade. Now, the real power of understanding this, and this is what I want you to grab, is that it forces you to think differently about your energy independence strategy. You stop thinking, what's the perfect single device? And you start thinking, what's the layered approach? Here's what this actually looks like in practice. You have your atmospheric antenna. It's trickle charging a small lead acid battery, the kind you probably already own if you've worked on a car. That battery is now holding a baseline charge. When there's sunlight, your small portable solar panel tops it off. When there's a storm or an emergency, your hand crank generator is there. Your heating and cooling costs are already cut because you've done the weatherization work we've covered before. This isn't one device solving everything. This is you stacking small wins. And on a fixed income, small wins that cost under $1 each are the wins that matter. Let me walk you through what this actually costs to build, because cost is the entire reason you're watching this. Here's what you need. First, the antenna itself. You need 6 feet of copper pipe, 1/2 inch diameter. At a hardware store or online, that's about $8 to $12. You can also use copper wire, the kind used in electrical installations, if you prefer something lighter. That runs $5 to $8. Next, you need sharpened wires for the top. These create the radiant points that increase surface area for atmospheric collection. You can make these from copper wire scraps, or you can buy a small bundle of copper wire and sharpen the ends yourself. Cost $2 to $3, or free if you have scrap lying around. You need a diode. This is the only electronic component. It lets the electrical potential flow one direction only, into your battery, not back out. A 1N4007 diode, which is what most people use, costs about 15 cents. You can buy a pack of 100 for $2 or $3. You need copper wire to connect everything. Again, scrap wire works perfectly. If you don't have it, a small roll of household electrical wire is $3 to $5. You need a ground stake. This is critical. It's what creates the electrical path into the earth, which is essential to how this works. You can use a copper rod. 8 feet long is ideal, but 6 feet works. Copper rods run $12 to $20. Or, and this is the budget option, you can use rebar from a construction site or recycled from old fencing. Cost $5 to $8, or completely free if you salvage it. You need an insulator to mount the antenna. This keeps the copper from touching metal or conducting materials directly. You can use PVC pipe, wood, or even ceramic. Cost $2 to $5 for materials. Finally, you need connectors, terminal blocks, or simple wire connectors to join everything. Again, scrap materials work, or you can buy a small pack for $1 to $2. Add it all up: copper, diode, wire, ground stake, insulator, connectors. We're talking $15 to $35 for the entire device. That's not a typo. $15 to $35. Now here's what this generates, and I want to be honest with you because I respect your time and your intelligence. A single atmospheric antenna like this generates between 50 milliwatts and 200 milliwatts under normal conditions. On very clear, dry days with high atmospheric pressure, you might see spikes up to 500 milliwatts. That's enough to trickle charge a 12-volt lead-acid battery at a rate of roughly 5 to 10 milliamps continuously. In practical terms, over 24 hours, this antenna is putting roughly 120 to 240 milliamp hours of charge into that battery. That doesn't sound impressive until you understand what it actually does for you. A single LED lamp, the kind used for emergency lighting, draws about 10 to 50 milliamps. So this antenna can power one LED continuously. A basic weather station draws 15 to 30 milliamps. A remote sensor for temperature and humidity draws 5 milliamps. Your small USB charging device, when not actively drawing power, charges at about 50 to 100 milliamps at 5 volts. With a step-up converter, which costs $5 to $10, you can convert the 12 volts from your battery to 5 volts for USB devices. What this means is that one $25 to $35 antenna can keep 3 to 4 low-power devices perpetually charged. No plugging into the wall, no grid draw, no bill. But let me tell you what makes this actually valuable on a fixed income. Over the course of a year, a typical American household uses about 10,500 kilowatt hours of electricity. That's the average. At 16 cents per kilowatt hour, that's $1.680 a year, just for the basic rate. But wait, your utility has base charges, transmission fees, delivery charges, and now, many regions have added grid services fees. The actual total bill is often 20 to 30% higher than just the kilowatt hour rate. So you're really paying around $2 to $2.200 a year. On a fixed income of, say, $8.00 a year from Social Security, that's roughly 8% of your entire income going to electricity. Now, you're not going to replace that $2,000 bill with a single antenna, but what if you layered them? What if you had 3 atmospheric antennas, each on a different post, each charging its own small battery, each powering different devices. Your cost is now $7.5 to $1. You've cut your lighting costs by 20 to 30% because those LED devices are now running from your batteries instead of the grid. What if you add a small hand crank generator? Another $10 to $15. Now you have backup power that doesn't depend on sun or sky. That's an insurance policy on your fixed income. What if you add one small portable solar panel, the kind that costs $40 to $80? Now your baseline battery charge is being topped off during daylight. You've cut your daytime lighting costs by half or more. You're reducing peak demand charges if your utility has them. This is a $150 investment total, maybe $200 if you buy everything new and don't have any scrap materials. And it's cutting 10 to 15% off your electricity bill. That's $2,000 to $3.30 a year back in your pocket. Over 5 years, that's $1 to $1.650. And the only maintenance you've done is checking the ground state connection once or twice a year. Now, the reason this works is something most people don't understand about how their energy actually moves. The electricity in your home isn't actually flowing from a power plant 100 miles away. That's the story. That's the narrative. But the reality is more nuanced. What's actually happening is electromagnetic induction and potential difference. Your utility creates a voltage potential at the plant. That potential creates an electromagnetic field that propagates through the wires. Your devices respond to that field by drawing current. The current flows through the return path, typically the neutral wire, and ultimately through the Earth itself. The Earth is essentially a giant conductor. It has natural electrical properties. When you drive a ground stake, you're tapping into that conductor directly. The atmospheric voltage I mentioned earlier, the 100 to 300 volts per meter of altitude, is real. It exists because of the ionosphere, solar-wind interaction, and the Earth's natural magnetic field. It's not free energy in the magical sense, it's natural electromagnetic potential that's been there since the planet formed. Your atmospheric antenna, combined with your ground stake, creates a potential difference. That potential difference drives charge carriers, electrons, into your battery. It's not much current, it's not fast charging, but it's real, it's continuous, and it costs almost nothing. The problem, and this is important, is that nobody's going to tell you this works because it doesn't generate a revenue stream for them. A utility company can't meter atmospheric potential. A battery company can't sell you a replacement for a natural phenomenon. A solar manufacturer can't mark it up 1,000%. But you can build it for $30 and use it for the next 20 years with zero maintenance and zero cost increases. This is why the complete technical guide and build instructions for this system are available in the description of this video and pinned in the comments. It covers everything from the physics behind atmospheric potential difference to the exact materials list with current sourcing information. Because people ask where to find these things. But the guide goes even deeper. It shows you how to layer multiple antennas for better output. It explains the math behind calculating your actual power needs. It walks you through grounding techniques for different soil types, because wet clay soil conducts electricity differently than sandy soil. It includes troubleshooting, because not every location generates the same voltage due to local atmospheric conditions. The reason that guide exists is because after you build your first antenna, you're going to have questions. The YouTube video answers the what, the guide answers the why, and the what if. Now, let me address something directly, because I've built these myself and I know what happens next. You're going to build this antenna. It's going to charge your battery. You're going to see that multimeter readings show real current flowing in. And your first thought will be, why doesn't everyone know about this? Your second thought will be, can I scale this up? The answer to the second question is not easily and not quickly, but not because it's impossible. There are researchers, not crackpots, but people with PhDs and published papers who've been working on atmospheric electricity capture for the last 15 years. Most of this work is published in peer-reviewed journals that cost $50 to access, so it doesn't go viral on YouTube. But it exists. In 2019, a group at MIT published findings on a concept called an air electrode battery. It uses the same atmospheric potential difference to create stored charge, but at a scale that's theoretically capable of kilowatt-hour generation, not milliwatt-hour. In 2021, researchers at UC Davis published work on what they called Earth battery systems, essentially large-scale grounding arrays that capture telluric currents. These are electrical flows that exist naturally in the Earth itself. None of this has made it to a consumer product. None of this is being commercialized. You know why? Because the infrastructure isn't there, the profit model doesn't exist, and the regulatory framework would take 30 years to build. But for you, on a fixed income, the current technology, a $30 antenna that gives you perpetual trickle charging, is the sweet spot. It works now, it costs almost nothing, it requires no permits, it doesn't depend on supply chains for replacement batteries, it just works. Here's what I want you to understand about the bigger picture. The utility industry didn't just happen to develop the way it did. It was deliberately structured to maximize revenue per customer, centralized generation, long-distance transmission, metered consumption, billing cycles. You are the product, and the product is measured in kilowatt hours sold. Everything else, efficiency, innovation, cost reduction for the customer, is secondary. It's not malice. It's economics. A $100 million transmission line doesn't get built if it reduces demand. A power company's stock doesn't go up if customers are using less electricity. This is why solar was actively opposed for 20 years. It's why battery storage is now being seen as a threat to grid stability, not because of physics, but because it means less demand for grid electricity. It's why something like atmospheric electricity, which produces real power at zero cost and zero regulation, has been completely invisible. Your job isn't to wait for the industry to change. Your job is to take back control of what you can right now with what you have. An atmospheric antenna is not a solution to your entire electricity bill. It's part of a strategy. It's a layer in a system. And the point of this channel, the entire reason I'm telling you this, is so that you understand there are more layers available to you than you've been told. You're going to save money. Over 5 years, with the layered approach I've described, you're looking at $1 raise to $2 raise. 1,000 back in your pocket from just the lighting and trickle charging portion. Over 10 years, that's $2 raise to $4 raise, 0.000s, and you've done it with maybe $2 raise of materials and weekend worth of work. But the real win isn't just the money, it's the independence. It's knowing that you're not entirely dependent on a grid that's aging, a utility company whose rates climb every year, and an infrastructure that wasn't designed with your interests in mind. And that's worth more than the money you'll save. That's the actual point of all of this. In the next video, we're going to show you how to combine this antenna with a small hand-crank generator to build a complete backup power system for under $50, and then how to scale it into a battery bank that can keep your critical loads running for days without the grid. Because you've earned the right to not worry about your power bill on a fixed income, and I'm here to show you how. Before you go, I want to make sure you have everything you need to actually build this antenna and understand why it works the way it does. We've put together a complete step-by-step ebook that breaks down every single component, shows you where to source materials for the cheapest price, and walks you through the assembly process so there's zero confusion. It's in the description and pinned in the comments. If you're serious about reducing your power bill this month, grab it. The reason I mention this is simple. Building one antenna is your first step toward independence. But understanding the physics, knowing how to scale this up, and learning how to connect it safely to a battery bank or small inverter, that's what separates someone who tinkers with a hobby from someone who actually cuts their power bill. The ebook shows you all of that. And more importantly, it shows you the math. How many volts you can realistically expect, how long it takes to charge a battery with this method, what size battery makes sense for your home, and how to know when you're actually ready to add a second or third antenna to increase your output. This is the kind of detail that the utility companies don't want you to have, because once you understand how simple this is and how affordable it is to get started, the entire narrative around you need to spend $20,000 to go off-grid falls apart. So grab that ebook from the description, go build your first antenna this weekend, start measuring your voltage on Monday, and then come back and tell us what you got, because you're not alone in this. Every single day, we get messages from viewers across the country who've built their first antenna, gotten it working, and suddenly realized that everything they've been told about electricity is incomplete. The utility industry has done an incredible job of making sure that people on fixed incomes feel trapped by rising bills. But you're not trapped. You've got options, you've got solutions, and they cost less than a trip to the grocery store. That's the community we're building here. That's the whole point of this channel. So thank you for watching all the way through. If this video helped you understand how atmospheric potential actually works, or if you're feeling more confident about building your first antenna, please hit that like button. It tells YouTube that this content matters to people on fixed incomes who want real solutions, not corporate talking points. And subscribe to the channel! New videos come out every week, and they're all built around the exact same idea. Practical, affordable, real solutions for cutting your power bill without needing permission from anyone. Activate that notification bell so you never miss a new upload. I'll see you in the next one. Keep building, keep learning, and keep taking back control of your energy.